Now that we've reviewed valence electrons, let's go over the octet rule. An octet is merely a set of 8. Now the octet rule states that atoms with a full octet of 8 valence electrons in their outermost shell are the most stable. This is why the noble gases are the most stable elements on all the periodic table, because they have a full octet in their outermost shell. No more electrons can get in there for them to react. Let's take a closer look at these noble gases. This is the Bohr model of neon. Neon has 8 valence electrons, that is 8 electrons in its outermost shell. And as you can see, all the other noble gases, they also have the same number of electrons in their outermost shell, making them very stable, making them unreactive. Argon, another noble gas, 8 valence electrons. Look at krypton. Count the outermost electrons. There are 8 valence electrons. And the pattern holds with xenon and radon. There is one exception, and that is helium. See, helium only has 2 electrons. However, it's still extremely stable because the first energy level of the helium atom can only hold 2. So no more atoms can come on, no more electrons can come on to that first energy level to make helium react. What makes these noble gases unique is that they all have 8 valence electrons, a full octet, which makes them the most stable out of all the elements. When other neutral atoms gain or lose electrons, they tend to do so in a way that gives them a total of 8 valence electrons. This is important when it comes to ions. That's why I spent so much time reviewing noble gases and valence electrons and octets. Other elements, other atoms gain and lose electrons in such a way where they come to their most stable form. That stable form being having 8 electrons in their outermost shell.